let's see an example of action rule. This action rule is composed of a pair of two other rules. Rule 1 says, for this table, this rule was extracted from this decision table. The rule 1 says if the value of attribute B is equal to P, this implies that the value of attribute D, which is the decision attribute, is equal to L. The blue ones, B and D, are flexible attributes. D is a decision. The rest of them, A and C, are stable. The decision, the values for decision are L and H. L means low profitability customer and H means high profitability customer. This rule can be extracted from the data by following layers or following a priori or some other algorithm. If we look at the data, we see if B is equal to P, then D is equal to L. If B is equal to P, then D is equal to L. That's pretty much a certain rule, 100% confidence. The next rule says if we have A equal to 2 and B equal to S, then D is H. Decision is high profitability customer. So this rule is supported by this object X7. The object X7 has A equal to 2, B equal to S, and the decision is H, high. So we can use these two rules by looking at them. This is the description of the low profitability customers, and our goal is to change the class from low to high. We want to make the low profitability customers become high profitability customers. So this is our goal. Now we know the description of the low profitability customers. They all have B equal to P. This could be their education, bachelor degree, for example. This one could be master's degree. So let's say bachelor degree, low profitability. Master's degree, high profitability. This is something that we can't change. Let's say this is their age, or this is their birth town, or something like that. So if they're born in that town and they have a master's degree, they're high profitability customers. For example, this is the description of high profitability. Now, what can we do to change from L to H? We look here. B is flexible attribute. If B is P, decision is L. If B is S, decision is H. We want the decision to be H, so we want to change B into S. So whatever is B, it has to change to S. So the action rule is saying B changed from P to S. Then we expect the decision attribute will change from low profitability to high profitability. So by using these two rules, we can compose action rule like that. I'm going to show example of how these action rules look like. action rule extracted from insurance database. It says private health insurance, if it changes from value 3 to value 4, then the contribution to car policies will change from 5 to 6. Another rule says if the education changes from level 2 to level 3 and the social class changes from 2 to 4, then the private health insurance will change from 3 to 4, or it will increase. Database. This is a breast cancer database. This is an example action rule. Uniformity of cell size will change from 8 to 1, and the normal nuclei from 5 to 3. Then the class will change from 4 to 2. So let's say this is malignant, this is benign. So this is what needs to happen in order to cure this tumor. That's what this rule is saying. Marginal adhesion changed from 1 to 3. The uniformity of cell size will change from 8 to 1, and so on. This is another example rule from a different database called binding to thrombin database. This is used for developing drugs and exploring the properties of certain chemicals where they can bind to this thrombin. So again, we can extract some action rules from that. In this case, the attribute was named F304 or F172 or something like that, but it says if this attribute will change from 0 to 1, then the class will change from 1 to 0, which is what we want. We're trying to change the class from 1 to 0. So the idea with these action rules again is to move our objects from a less desirable class to a more desirable class by extracting rules that will show us certain actions that we can take with flexible attributes, the attributes that can change. So before we start this action rule extraction, we have to mark which attributes are stable, and which are flexible, and which is the one that we're interested in, the class or the decision. One more thing I would like to show is how to compute the support and the confidence of these action rules. Now, our rule looks different than just this rule. So this rule, A2 implies C2. It's easy to compute the support and the confidence because the support is equal to the number of times A2 and C2 occurred together, and the confidence is the number of times A2 and C2 occurred together divided by the left side, which is A2. Now, when we have action rule, it's a little bit more complex than that because it says if A will change from 2 to 1 and B will change, almost stay the same, then D changes from 1 to 2. In order to compute support and confidence for this type of rule, we need to use 4 different sets The first set, called Y1, is the one in red color. It's the one on the left side, which means these are the current values of these objects. So this is the current value. The yellow ones are the values that we want to change to. So we wanted to change from A2 to A1. Currently, the value is equal to A2. These are the red ones. So eventually it will be equal to A1 if we manage to change it. But the first set is the current values. So A is equal to 2 and B is equal to 1. The first set contains the objects which have property A2 and B1. A2 and B1. These are X2 and X4. That is the first set that we need. The next set is Y2, the yellow ones, the ones that on the right side, the ones that we would like to change into. So A1 and B1, there are two objects that have property A1 and B1. That's object X1, A1, B1, and X6. So this is the second set, X1 and X6. The third set is the set that is for the decision attribute. Again, the value on the left side is the current value, and the value on the right side is the one that we'd like to accomplish. Low profitability, move to high profitability. So, purple, pink one, this one, is the set Z1. All the objects that have property D1. This is X1, X2, X3, X4, X5, and X7. So that's the set Z1. And the last set is the objects that have the value we would like to change into. That's D2. There's only one object with property D2, the green one. That's X6. So once we compute these four sets, we can use them to calculate the support and the confidence of the action rule. The support is the intersection of the set Y1 and Z1. So the intersection of this set is, what is the intersection between Y1 and Z1? X2, X4, right? There's X2, X4 here and X2, X4 here. What is the cardinality of that set? X2 and X4? 2, because 2 is the number of cardinality is the number of objects in the set, and we have two objects, X2 and X4. So the cardinality of the set is 2, that support is equal to 2. The confidence will be equal to this divided by Y1, which is 2 divided by 2 is 1 times cardinality intersection of Y2 and Z2, 1, which is 1, and cardinality of Y2, 2. So 1 over 2. 1 times 1 over 2 is 1 over 2, so the confidence is 1 over 2 for this rule.